Today we begin solve the multiple integral and begin with evaluating the integrals in first integral from 0 to 1 of integral from 1 to 2 of x squared plus y squared dx dy. Firstly, we must integrate the integral. It means we calculate integral from 1 to 2 of x squared plus y squared dx with respect to y. The first integral from 1 to 2 x squared plus 1 y squared dx. We consider that y is constant. In this case, we will have integral of x squared with respect to x is x cubed over 3. Then plus this plus. Then integral of y squared with respect to x, if we think that y is constant, it is y squared constant times integral of dx is x. And double substitute from 1 to 2. From 1 to 2 with respect to y. Substitute integral from 0 to 1. Firstly, x is 2 in this place and in this place. X is 2. We will have 2 cubed over 3 plus y squared times 2. It is upper limit, then minus lower limit. Substitute x is 1 here and x is 1 here. We have 1 cubed over 3 plus y squared times 1 with respect to y. Calculate integral from 0 to 1. 2 cubed is 8 over 3 plus 2y squared minus 1 cubed is 1 over 3 plus y squared dy. Open these two brackets. We will have integral from 0 to 1. Of open this bracket, is 8 over 3 plus 2y squared. Then minus 1 over 3 and minus y squared. dy equals integral from 0 to 1, 8 over 3 minus 1 over 3. It is 7 over 3. 2y squared minus y squared. It is plus y squared. dy equals find integral 7 over 3 with respect to y. It is 7 over 3 times y. Then y squared dy, y cubed over 3. Double substitution, 0, 1. Substitute y is 1 here and here. 7 over 3 times 1 plus 1 cubed over 3 minus our limit. We have 7 over 3 times 0 plus 0 cubed over 3. It is 0, and in the first 7 over 3 plus 1 over 3. It is 8 over 3. This is answer. Is it clear or not? Do you understand this?
Yes.
Okay. The third integral. Integral from 1 to 2x of integral from x to square root of 3 xy dx dy. It is integral from 1 to 2x of integral of x to square root of 3 xy dx dy. In an integral, we will have integral from 1 to 2x of integral of x y with respect to x is y times x squared over 2. From not very good. It is dy dx y, because look, this x, because we cannot integrate with respect to x. Y is x, y is root of 3 y. It is not true. Here x and here x. Not maybe it is mistake in the condition. I think in this case y, stay y. It means very good. But 2x, y to x, not can be 2x. Just 2 stay. it is mistake in the book. Calculate 0 to 2, then x squared over 2 times y, from y to square root of 3 dy, and calculate. X is square root of 3, firstly. Square root of 3 squared over 2 times y. Then x is y in this case. This place. We will have minus y squared over 2 times y dy. Calculate. Then 3 over 2 times y divides 3 over 2 times y squared over 2 minus y cubed over 2, it is y to the power of 4 over 8 from 1 to 2, and we have 3 over 4, 2 times 2 is 4. 2 squared minus 2 to the power of 4 over 8 minus row limit 3 over 2 times 1 squared over 2 minus 1 to the power of 4 over 8. Calculate. 2 squared and 4 we can delete. We have 3 minus 2 cubed, it is 8, 2 minus 3 over 4 minus 1 over 8. 1 minus 2. 3 times 2, 6 minus 1 is 5. It is 3 over 8. Is it clear?
Yes.
Good. 5. Integral from 0 to a of integral from x over a to x dy dx over x squared plus y squared. It is integral from 0 to a of integral from x over a to x over x squared plus y squared. And then look, here x, because we cannot integrate with respect to x, we must integrate with respect to y, dy and dx. Calculate. If y is variable, x is constant, we will have x integral of x over a to x of dy over x squared plus y squared dx. This is stable integral, it is arctangent. It will be 1 over y arctangent of x, y over x, 1 over x, arctangent of, because with respect to y, of y over x, from x over a to x dx. We can cut x out and we will have integral from 0 to a of tangent of x over x minus tangent of x over a over x with respect to x. We'll have integral from 0 to a. Arctangent x over x is arctangent 1. Minus arctangent 1 over a. Arctangent 1 is pi over 4. And we have pi over 4 minus arctangent 1 over a times x from 0 to a, or just a times pi over 4 minus arctangent 1 over a. Is it clear? Do you understand it? Okay. Number 7. Integral from b over 2 to b of integral from 0 to pi over 2 of rho d theta d rho. It is integral from b over 2 to b rho of integral from 0 to pi over 2 of d theta d rho. Integral of the theta is theta, and we have integral from b over 2 to b of rho times beta from 0 to pi over 2 d rho equals integral from b over 2 to b of rho times pi over 2 d rho. This pi over 2 we can take out integral as constant. Integral of rho d rho is rho squared over 2 from b over 2 to b. We have pi over 2 times b squared over 2 minus b over 2 squared over 2 or pi over 2 times b squared over 2 minus b squared over 8. Therefore, we will have pi over 2 times 4 minus 1 is 3 b squared over 8, and in the end we will have 3 pi b squared over 32. Is it clear? Do you understand all of this? Now I give you the screenshot of board in the chat and clean this board. I sent this board on the chat. This group 2202. In the class Ali Abdallah Mohammed Khalil,
Yes, ma'am.
Al-Furaiji, Ben Said Ramzi Rauf, Bit Mejidis Ray, Grace Bishoy Adel Mikhail, Gusay Kamal, Jamin Ayub, Avad Suleiman Ibrahim, Adel Jefferson Sabiti, Amar Kamaluddin Hussein Yildiz, Hassan Hassama, and Hussein Hassan Ahmed Rahmetullah. With you exist another student, not I say, and we can.
Yes, doctor.
Yes. What? Abdurrahman.
Didn't say Abdurrahman Ahmed Fahmi. Didn't say.
Abel Sud. Yes, I checked. Next. next numbers, we must determine the limits of integration for the integral double integral over d of f of xy dx dy, where the region of integration is bounded by the lines nine. Y is 0, y is 1 minus x squared. The line y is 0 is x-axis. The line y is 1 minus x squared. It is 1. Then 1, 1. No, squared. This line line. The points of intersection of this line, it is A with coordinate -1 and 0 and B with coordinate 1 and 0. It Yes, Adele, if you send all your homeworks, you will get 3 before the exam. It is clear. Look, x change from -1 to 1. Y change from y is 0 from this line to y is 1 minus x squared to this line. Because it our integral over d of f of xy dx dy will be equal to integral, firstly, from -1 to 1 of integral from 0 to 1 minus x squared f of xy dy dx. Is it clear? Understand it?
Yes.
Next, 11. Y is 2 over 1 plus x squared and y is x squared. What? Y-axis, x-axis, 0. Find the points of intersection. Two over 1 plus x squared equals x squared. 2 equals x squared times 1 plus x squared. We will have x to the power of 4 plus x squared minus 2 equals 0. It is b square equality. Discriminant or not. Minus 2 is minus 2 times 1. X squared is minus 2 or x squared is 1. this is not solution. In this, x is -1 and x is 1. Consider the first line, y is 2 over 1 plus x squared. If x is -1 and if x is 1, y is 1. Okay, these 2 points. If x is 0, y is 2. Oh, not. Maybe 1. Oh, or not. Maybe here we have 1. 1. Okay. Here 1, this 2 point and 2. Okay. If x is 1 over 2, for example, 2, I'm sorry, 1 plus 1 over 2 squared is 2. 1 plus 0.24. This 1 and 6. This 1 and 6 here. This. And this. Okay. It is line y is 2 over 1 plus x squared, and y is x squared. It is very easy problem. It means x change from -1 to 1, from -1 to 1. And y change from this line, y is x squared, this line, to this line, y is 2 over 1 plus x squared. And our integral integral over d of f of xy dx dy will be equal to integral from -1 to 1 of integral from x squared to 2 over 1 plus x squared of f of xy then dy from this to this dy. Then dx. Do you understand it? Is it clear?
Yes.
Okay. Now I give you the photos of this board. The chat. Clean this board and we continue. In next examples, we must change the order of integration in the integrals. And first number 13. Integral from 1 to 2 of integral from 3 to 4 f of x y dx dy. Y-axis, x-axis. In this case, x change from 3 to 4. Y change from 1 to 2. X is 3. It is the line that parallel y-axis and lie, the point x is 3 lie in this line. This is x is 3. Then x is 4. X is 4. this line. X is 4. Oh, sorry. This line. X is 4. Then y is 1. It is horizontal line. The point y is 1. Okay, in the line. And y is 2. It is this line. It means x change from 3 to 4 between these two lines. Y change from 1 to 2 between these two lines. And our region of integration is this square. Change the order of integration. Firstly, we must define y. Y change from the line 1 to the line 2. Y change from 1 to 2. And x change from x is 3 to x is 4. X change from 3 to 4. It means that our integral we can rewrite as integral from 3 to 4 of integral from 1 to 2 f of x y dy dx. Do you understand it? Is it clear? Students, clear or not?
Yes.
Yes. Next, 15. We will have integral from 0 to a of integral from 0 to square root of 2ay minus y squared of f of xy dx dy. It means x lies between 0 and this root. And y lie between 0 and a. Construct. Y 0 x x is 0 is the y-axis. X is 0. Y is 0 is x-axis. Y is a. Y is a. It is horizontal line that come between y is a. And x is this root. X is square root of 2ay minus y squared. It is x is positive. X squared will be 2ay minus y squared. X squared plus y squared minus 2ay equals 0. Then x squared minus or plus y squared minus 2ay plus a squared equals a squared. And this expression, it is full square or y minus a squared. This is secondary school formula. This is circle with the radius square root of a squared. It means a and with the centers with coordinate x is 0, y is a. But if x is positive, it is semicircle. Semicircle that lie in the upper part of our plate. It means upper x-axis. Here x is 0, y is a. This center of circle, maybe I wrote the center of circle. Then radius a. Radius a, it means we will have semicircle. Approximately this. And y x from x not semicircle. X is positive, means semicircle in this case. In this x is positive, right part. Not right. X is positive. X is greater than 0. Okay. Okay. Look, y from 0 to a between these two lines, and x from 0 to this line. And we will have this part of circle. Okay. Then we must change the variable. Inner integral will be with respect to y, and look, x, here a, x change from 0 to a, from 0 to this line a. Y change from this line to this line. Here, find y. This line is x squared plus y minus a squared equals a squared. It means y minus a squared will be equal to a squared minus x squared. And y minus a equals plus or minus square root of a squared minus x squared. But this part lies lower that line y is a, the line of symmetry of circle. It means we will have minus because lower this line y is a. It means y is a minus square root of a squared minus x squared. And y change from this line, this curve a minus square root of a squared minus x squared to the line y is a. And our integral, our first integral, this changing of y, integral of 0 to a, integral of 0 to square root of 2ay minus y squared, f of x, y, dx, dy, will be equal to integral from 0 to a. It is changing of x. It is dx of integral from this expression a minus square root of a squared minus x squared to a of f of x, y, dy. Okay. Is it clear? Do you understand it? Okay. Next example, example 17. 17. We will have integral from 0 to 1 of integral from minus square root of 1 minus y squared to 1 minus y of f of x y dx dy. In this case, x change from this to this, from minus square root of 1 minus x squared to 1 minus y. And y change from 0 to 1. Plot these lines and curves. Y axis, x axis. The first, x is minus square root of 1 minus y squared, x negative. It means x squared will be equal to 1 minus y squared, or x squared plus y squared equals 1. It is circle. With the center in the unit and in the origin, and with radius is unit. Radius is 1, but x is negative number. Negative number. I can take this. X is negative number. It is any circle. This x is negative. Approximately. Not very good. Maybe I try to it. This line circle with coordinate is the center is origin. Okay, it is x is minus square root of 1 minus y squared. 2 x is 1 minus y. X is 1 minus y is just straight line that consists the points x is 0, y is 1 and y is 0, x is 1. This line. It means x change from this line to this line. Okay. Very good. Y change from 0 to 1. Here 0, y is 0, from 0 to y is 1 is this line. It means we will have this region of integration. Then we must change the order of integration. Look, if x change from curve to curve, that x must change from point to point, from -1 to 1. But if we take changing of x from -1 to 1, we cannot define changing of 1, because if x change from -1 to 1, y change from 0 to how line? In the first case, from -1 to 0, we will have from 0 to this line. And in the second case, in this case, we will have from y is 0 to this line. Okay? Because we must define changing of variable to two parts. The first, x change from -1 to 0. In this case, y will be changing of y is 0, this line, to y is, we must define y from this x squared equals 1 minus y squared. From this y squared equals 1 minus x squared, and y is upper semicircle because it plus square root of 1 minus x squared. From 0 to plus square root of 1 minus x squared. It is the first part of integration. The first part of our area of integration. The second part, x change from 0 to 1. In this case, y will change from y is 0 to y is 1 minus x. And our integral will equal to sum of two integrals. The first integral, this integral from minus 1 to 0 of integral from 0 to square root of 1 minus x squared of f of xy. In the first, dy change from 0 to this. Then dx. Plus the second integral from 0 to 1 with respect to x, and integral from 0 to 1 minus x. F of xy dy dx. Do you understand it? Is this clear? Understand?
Yes, dear.
Okay. Now I give you this board. Okay. I sent and maybe stop our lesson in this moment because we cannot consider next theme, next topic. Not very easy. in next class we begin with computing the integrals by changing to polar coordinates. In this class we must solve numbers from 1 to 17 of this term by Piskunov book. Now I create your homework and you must send it to assignment. Half of these numbers, all odd numbers, we solved today. Other number we must solve yourself. Understand me?
Yes.
Yes. Now I create your homework and we stop our class.